I've worked here 8 years, and you won't believe how insane this actually is. Ready? Let's go.
It all begins here, with two primary ingredients: traditional iron ore. First, the iron ore. Billions of tiny pellets are transported for their initial treatment. Mixed with coke for fuel and limestone to remove impurities during the melting process.
This mixture is sintered, baked into larger chunks that allow for better airflow in the blast furnace.
Ever wonder how the backbone of our world is forged? Today, we're going inside a state-of-the-art
Simultaneously, we process recycled steel, a critical part of modern production. In 2025, AI-driven robotics sort the scrap with incredible precision, ensuring purity. Large items are shredded and compacted into dense bales for efficient melting. This sorted scrap is now ready for the next stage, the furnace. Meanwhile, coal is baked in airless ovens to create high-purity coke. This coke will provide the intense, consistent heat needed to smelt iron. Two paths, one goal: to create pure, molten metal. For iron ore, the journey continues at the blast furnace, a titan of industry.
This charge is carried to the top, ready to be fed into the belly of the beast.
The furnace is charged, and the transformation is about to begin.
From a central command center, every variable inside the furnace is monitored in real time.
A continuous blast of superheated air ignites the coke, generating immense heat. As the materials travel down, the iron ore melts and releases its iron. After several hours, it's time to tap the furnace.
Thousand tons of iron melt here every single hour.
The core temperature is spiking near the south vent. Adjust the flow rate now.
This is molten iron, or hot metal, the primary product of the blast furnace. The limestone has done its job, binding to impurities to form a waste product called slag. This iron is still rich in carbon and must be refined into steel. This happens in just 0.8 seconds in real time.
Now, let's look at the recycling route, the electric arc furnace.
The furnace is charged with the carefully sorted recycled steel scrap. These massive graphite electrodes will act like a bolt of lightning.
An enormous electric current creates an arc, with temperatures reaching 3,500 degrees Celsius.
In under an hour, the entire charge is melted into molten steel. The furnace is tapped, and the liquid steel is ready for the next crucial step. Whether from iron ore or recycled scrap, we now have raw, molten metal. But this is not yet the final product. Now, it must be refined to perfection.
The hot metal from the blast furnace is charged into a basic oxygen furnace to remove excess carbon. A high-purity oxygen jet ignites the carbon, creating a violent chemical reaction that refines the iron into steel. This process is incredibly fast, refining over 300 tons of iron in just 20 minutes.
Regardless of the initial method, the steel's chemistry must now be precisely adjusted. Samples are analyzed instantly, giving engineers a precise chemical breakdown.
The steel is then moved to a ladle metallurgy furnace for fine-tuning.
This is where recipes are made. Alloys are added to create different grades of steel, from stainless to high-strength structural.
Each addition subtly changes the steel's final properties, its strength, corrosion resistance, and flexibility.
Argon gas is bubbled through the mixture to ensure the alloys are evenly distributed and to remove any remaining impurities.
For high-grade steels, a vacuum degasser removes dissolved gases like hydrogen, preventing internal defects.
The chemistry is now perfect. The molten steel is ready to be given form.
The journey from liquid to solid is about to begin in a process called continuous casting. The ladle is positioned above the continuous caster. The steel flows into a tundish, which acts as a reservoir, ensuring a constant, steady flow into the molds below.
As the steel passes through a water-cooled copper mold, a solid shell is formed, marking the birth of solid steel.
This continuous strand is drawn out of the mold, still molten on the inside. A secondary cooling zone with water sprays solidifies the steel completely as it's guided horizontally. What emerges is a continuous slab, billet, or bloom, depending on the desired final shape. Automated torches cut the strand into manageable lengths without ever stopping the process. These slabs are now sent to the hot rolling mill to be shaped. They are reheated to a precise, uniform temperature for optimal malleability. First, high-pressure water descales the surface, ensuring a clean finish.
Then, the rolling begins. A series of massive stands, called roughing mills, perform the initial reduction in thickness.
It then accelerates through the finishing mills, reaching its final thickness at incredible speeds. Thousands of sensors monitor every millimeter of the steel to ensure perfect uniformity.
The cooling rate is precisely controlled to achieve the desired metallurgical properties.
Finally, the finished hot-rolled steel is wound into massive coils.
Alternatively, blooms can be rolled into structural shapes like beams for construction.
One coil equals steel for 25 cars, or one wind turbine tower.
Each product is marked with a unique digital identity, tracking it from creation to customer.
This entire process, from liquid to solid coil, is a marvel of modern engineering.
For applications requiring a smoother surface and higher strength, the steel is cold rolled.
This process further reduces thickness and enhances the steel's surface finish and strength.
To protect against corrosion, many steel products are galvanized, receiving a coating of zinc.
This protective layer will shield the steel from the elements for decades.
Quality control is paramount. Non-destructive testing, like ultrasonic scanning, ensures internal integrity.
If it's not perfect, made at pleat, it gets recycled immediately. Every batch is refined and tested for quality. Physical samples are tested to destruction to verify their strength and ductility meet exact specifications.
Every single batch must pass a rigorous battery of tests before it can be shipped.
Every coil is checked before leaving the facility.
Approved steel is moved to the distribution center, a highly automated logistical hub.
Robotics and automation handle the heavy lifting, ensuring safety and efficiency. By rail, road, and sea, the finished steel begins its journey. To become the cars we drive, the buildings we live in, and the infrastructure that powers our future.
Modern steelmaking is a symphony of power, precision, and a growing commitment to sustainability.
That's exactly how the world's strongest steel is made in 2025. Absolutely insane, right? Smash like if your mind is blown.